Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem split array largest sum. So this is a hard level question and it's the problem of the day on Geeks for Geeks today. So let us go through the question now. Given an array ARR of n elements and a number k, split the given array into k subarrays such that the maximum subarray sum achievable out of k subarrays form is minimum possible. So find that possible subarray sum. Okay, so that is a pretty straightforward question. So thing is, you need to divide. The very first thing that you need to do is you need to divide the array into k subarrays, and such that the maximum possible out of it is minimum possible. Okay, so there are various ways you can actually split an array into k possible subarrays, isn't it? So out of all those possibilities, you need to return that particular sum. That is the maximum out of each case, and it is the minimum out of all the possible cases. Okay, so it might be confusing at this particular point of time, but let us use the examples to dig deep and understand. And these are the constants that are that are given. Time complexity is O of n times log of sum of array, and expected space complexity is O of 1, and constants n goes up to 10 power 5 and k goes up to n, and array of I goes up to 10 power 4. So these are the company tags, and even topic tags gives you a lot of hint about the approach that you need to follow. So let us go through the question now in examples. So this is the example given, and why is this output, here the output is 4? Why is that so? So if you actually see the explanation given, the optimal split is 1 2 as one subarray, and 3 as one subarray, and 4 as one subarray. Total how many subarrays? 3. So k equal to 3 is being followed. That is for sure. That must be followed for sure. Now your thing is, you need to cut it in such a way, or you need to form it such a way so that the maximum sum of all subarrays is 4 now, right? So here the sum is 3, here the sum is 3, here the sum is 4, and which is minimum possible for 3 splits. Okay, minimum possible for 3 splits. So now in this case you have got the maximum sum to be 4. Now let us assume you are not dividing like this. Okay, let us assume you are dividing in this fashion. 1 2 3 4, this is a subarray given, right? Let us assume you are taking these two as one part. This is one part, this is one part. In that case, what is the sum here? This is 1, this is 5, this is 4. Now what is the maximum sum here? Maximum sum possible out of these three, that is 5. Is this 5 less than this previous result or not? No, it is not. 5 is greater than the previous result, that is what previous maximum. So that is the reason this cannot be considered. So what am I telling you is, out of all the different possibilities, okay, out of all the different possibilities of cutting this particular array into k sub arrays, find that sum. Okay, find that sum that is maximum among for that particular subarray, but minimum among all the subarrays possibilities. Okay, that is what I'm telling you. So in this possibility, the maximum sum that you have got is 5. In the previous possibility, the maximum sum that you got is 4. And in another possibility, what is another possibility here? So put 1 2 3 4 like this. You can say that I'll be cutting these two as one part, this one as part, one part. So in this case, the sum is 1, this is 2, this is 7. So what is the maximum possible sum here? 7. So out of all the possibilities, what are all the possibilities? This is one possibility, this is one possibility, this is one possibility. Is there any other possibility? No, there is no other possibility. So in that case, what is the maximum minimum among all the sums? So 4 5 7. So what is the minimum among all these two? That is actually equal to 4. That is the reason the output is 4. I hope you people have understood, right? So this is the task that has been given to you. That's it. So I hope you people have understood the question properly. And now let us frame the approach. What is the naive approach or brute force approach that you people can come up with? Very easiest approach, or the first approach that comes into your mind. So everything, any problem that is given to you in terms of coding or something related to your daily life, okay, related to your the problem that is given in front of you physically, and you're trying to solve it. Okay, so the same thing, if this particular array elements 1 2 3 4, let us assume I'm extending it to 5 6 7. Okay, these are the elements, or like array that has been given to you, and now you need to frame sub you need to divide this into k sub arrays. Okay, k can be equal to 3 or whatever the value that has been given in the question. Now what is your approach? What is your naive approach that you're going to do? So if you'll be starting on this particular element for sure, right? You'll be starting on this particular element for sure. You'll be starting on this particular element for sure. There are two choices from there. Either you can say that no, I'll only confine this one element to be a particular subarray, right? So either you'll confine this whole one element to be a particular subarray, so that here your number of subarrays would be 1. You have already formed one subarray, and still you need to form two subarrays with this whole element, right? So there are two choices. What is the first choice? The first choice, you'll be saying that okay, this particular one I'll be considering as one subarray. Okay, I'll not be including any more elements in this particular subarray. Only this one will constitute a particular subarray. And still how many are left? Because you have already formed one subarray, now how many are left? K minus 1, that is actually equal to 2. So you'll be trying to make two subarrays out of this all possible elements. This is one first case. Okay, this is first case, this is first case. What about the second case? What about the second case? You might say no, you'll tell the opposite of this. You'll not say, you'll say that no, I'll not confine the only one subarray to this particular one. I'll try to add some more elements. I'll try to add some more elements. I don't know how many I'm going to add, but I might add 2, 3, 4 until so on. But how many maximum elements can you add in that particular case? So out k equal to 3 subarrays you need to find. So I would say you can only add the elements to this first subarray till this point. You can add 1 2 to make one subarray, or 1 2 3 to make one subarray, or 1 2 3 4 to make one subarray, 1 2 3 4 5 to make subarray. But you cannot take 1 2 3 4 5 6. Why is that so? Let us assume you are taking this to be also particular subarray. So these all elements to be one subarray. And now how many elements are there? One. Now one element is there, and you need to find how many, you form how many subarrays? K minus 1, that is actually equal to 2, because this whole thing is one subarray. So still how many are there? From T minus 1, that is actually 2, and you have only one element. You need to form two subarrays. Is that possible? No, it is not possible. So that is the reason the maximum thing that you can add, okay, from starting a particular element, okay, starting from a particular element, let us assume you're starting from here, you can only go till up to n minus k. Okay, what is n minus k? So this particular n is in this case 1 2 3 4 5 6 7 7, right? So 7 minus 3, that is actually equal to 4. So 0 1 2 3 4, only till fourth index you can go up here. Okay, and after that you cannot go, you cannot include elements after that, right? I hope I'm making sense, because once you include it, you'll be making a subarray such that the remaining elements will be less than the number of subarrays that are yet to be formed. So that's the reason you'll never do it. So you'll only keep a restriction to this. So what are the choices available? Either you can go with only this particular one element as one subarray, that is the first case, or you can try adding some more elements to this subarray. Now while doing this particular thing, okay, while doing this particular thing, so this is the naive approach that I'm talking about. This is not an optimal approach. So in short, you're actually trying to form all the subarrays, right? First case, you're taking a case of only one particular thing. Second case, you're trying to add elements. So this is a recursion type of thing. Okay, so for this is the first case that you'll take. So if you're taking only this particular one as one subarray, that means the how many still you there need to make, there are k minus 1 n minus 1 elements that are there, n minus 1 elements that are there, and k minus 1 subarrays that you need to form. Okay, this is one case. And whereas this you're considering at one as one subarray. So let us assume this from this the sum that you have got is 1, and from this the maximum sum, you let us assume some other some temp or something. So now out of these two, what would be the minimum maximum thing that you'll return? Okay, I hope I'm making sense. So you'll be working on this particular thing, and once you reach the end, you'll be checking if you are able to make k minus 1 to be 0. If k minus 1 equal to 0, that means you have formed all the subarrays. Now out of all the subarrays, you'll be keeping another temp to make to calculate the sum in each and every subarray, and take the maximum among all of them. That is the brute force approach. If you are not able to code it on your own, let me know. I'll even send the code, put it in the comment section. Okay, so that is a way that you can solve this particular question. It's just that you need to put a certain restrictions, and then you can just figure it out on your own. Okay, the code would be very very evident, and it can be easily written. And this is a brute force approach. But what is the optimal approach for this particular question? What is the best approach to this particular question? So if you carefully observe in the question, it has been given what it has been given in the question. K goes up to n and starting from 1. Okay, k goes up to n starting from 1. K ranges 1 to n. Okay, k ranges 1 to n. So let us assume k equal to 1. K equal to 1 in the sense there is only one subarray that you need to find. So if that is only one subarray that you need to find or you need to frame, that means you need to take all the elements of the subarray, right? You need to take all the elements. So all the elements in the sense sum. Okay, sum of the array, that would be the maximum value. But if in case k equal to n, that means you need to divide the n element subarray into n parts. That means each element will constitute one subarray. So in that case, what is the maximum possible among all the sums? That is the max element, right? Max element is the maximum element of all this. So let us assume the array that has been given to you is 1 2 3 4 5 6 7. Okay, this is the array that has been given to you. Let us assume k equal to 1. Okay, k equal to 1. K equal to 1 in the sense all these elements must be a part of one subarray. That's it. There is no other subarray that you need to find. So that means this case, what is the maximum sum? maximum sum possible 1 plus 2 plus 3 plus 4 plus 5 6 7, so that is actually equal to 35 if I'm not wrong. So 3 6 10 15 21 28, yeah 28, sorry. And if in case k equal to 7, because 7 n equal to 7 in this case, so k equal to 7 in the sense that what would be the maximum sum in that case? Maximum sum is that actually equal to one particular element will make one subarray. So in that case, what is the maximum among all these possibilities? 7, because this is the maximum element. So this is the relation that you can find. So if k equal to 1, say take all the elements. If k equal to n, take the maximum possible element. Okay, that is the thing. Now k can oscillate between 1 to n, right? K range is this, so k can oscillate between 1 to n. So similarly, our maximum possible 7 is sum is in this case is 7. In this case it is 28. So similarly, our maximum the final answer will oscillate between these two values. That is important to recognize. Okay, that is the logical part here. So k oscillates between 1 to n. Similarly, so we have found the answer when k will be there 28. When k equal to 7, the answer is 7. So when k oscillates in between any of these values like 1 to 7, like k equal to 2 or 3, some other value, similarly our final answer will also oscillate. It depends. Okay, it depends. That is what you need to write code for. I hope I'm making sense to you. So in this fashion it is varying. Now you need to come to and understand how do we come to a conclusion in finding that particular sum. Okay, so you have got the least value of sum is so I'll just erase this part. So least value of sum is least value, okay, or least value least value possible. In this case, that is k equal to n. So in that cases, maximum element, okay, maximum element, or highest value possible, or largest value possible, okay, largest value possible. In which case k equal to k equal to 1. In that case, you will be taking all the elements to be a part of one subarray. So in that is equal to sum. Okay, sum of all elements. So this is the higher bound and lower bound and higher bound. This is the lower bound. Okay, this is the higher bound. I hope I'm making sense. So you have got the least possible value of output final answer and highest possible value of the final answer. So, right. So if your k comes out to be n, in the question k is n, return this particular lowest value. If k equal to 1, return this particular highest value. But if k is in between any of them, none you need to do, because now you have got the lowest particular value and you have got the highest particular value. You need to find the you also know the final answer will lie between somewhere else. What is the best algorithm that you can use here? It is binary search, right? Binary search, because you know the lowest value, you know the highest value, and you also know the answer will vary accordingly the particular k value, right? If k comes out to be anywhere in between, you'll also get the final answer somewhere around these two, right? I mean between these two elements. So that is the thing that you can come up to a conclusion. So you'll be framing a binary search on this particular sum. But how are you going to do it? So let's take this example itself. 1 2 3 4 5 6 7. Like, let us take this example and let us assume I'm telling that k equal to 3. Okay, k equal to 3. So k equal to 3, starting from this particular element. Okay, starting from this particular element. Now you got the lowest value. What is the lowest possible value? What is the lowest possible value of this particular final answer? That is actually equal to the maximum element, that is 7. And what is highest value? That is actually sum of all the elements, that is 28. Okay, now take the mid value. How are you going to do the binary search? I hope you people know it. Mid value is equal to sum low plus high divided by 2. So 28 plus 7, 35 by 2. So that's actually equal to 17. Okay, 17.5, but in computer language it is 17. I hope you're making sense. So mid equal to 17. Now what is the thing that you're trying to do? If you're able to, okay, if you're able to split this particular array, okay, if you're able to split this particular array in k or less than or equal to k or k, such that the maximum possible sum is coming out to be 17. Okay, the maximum possible sum that is coming out to be 17, then you look out for trying to split the array so that maximum attainable sum is 16. Okay, now we have got 17. Now your greed has been, now your target has been satisfied, but we are all greedy. We all look out for something better. So now we are trying to decrease, because that is a final vision of yours. So you're trying to decrease. So you're trying to decrease to from 17 to 16. If it is possible, you'll try to check. If it is not possible, then this would be your answer. If it is possible, you'll still again decrease it. That's it, right? I hope I'm making sense. But why am I saying less than or equal to k? Okay, why am I saying less than or equal to? But in the question it's been clearly mentioned equal to k. Why am I saying less than or equal to k is feasible? Because if you are able to, right, it's very common sense. If you are able to make an array, okay, if you are able to split an array, okay, if you are able to split an array such that taking only make, if for example I've told you to split it into 3 subarrays, but you have splitted that into k equal to 2 subarrays, and you're telling that in that case only you're getting the minimum possible maximum sum. Then I'm saying, okay, if you're getting like this, why don't you split it further? Okay, if you're splitting like this, let us assume you are split like this. So this is 1 k equal to 1, this is k equal to, like, 2 subarrays you have got, but your final target is to make k equal to 3. Then I'm telling you, why don't you divide a subarray into another part? In that case your maximum sum will still be reduced, right? So, or you can just do it on another subarray, making sure the maximum sum still remains the same, right? So you can still, or you can even this particular divide this particular elements in further subarrays. So it is completely possible. Why are you restricting yourself? You have already come to a conclusion that if you're k equal to 2, then you're getting a particular sum, and that is minimum most possible maximum. Okay, minimum maximum there. Now we are trying, now I'm telling you, why don't you divide another subarrays into all further parts? It doesn't make any difference, right? It still remains the same. So that is where it comes from. So even if it's less than or equal to k, it's completely fine. But if you're getting a, if you're trying to figure out the maximum sum possible by dividing into greater than k, then that is a problem. Okay, you're taking number of subarrays is greater than k to make the final answer or final maximum answer to be least possible thing. That is not feasible. You need to put it in less than or equal to k, right? That is, I hope I'm making sense. So now you'll do this binary search. Now you'll try to do it on, you'll try to check if mid equal to 17. So if you're able to attain the least possible sum or least maximum possible to be 17. So how are you going to check that? So I'll just write this array once again: 1 2 3 4 5 6 7. Okay, so this is what I'm writing again. Now how are you going to do? So k equal to 3 is what I've given. So start from this particular element, basic common sense. Okay, start from this particular element. Now you'll try to check, you'll add this particular element, if you can add this or not. How are you going to check? So the maximum sum, you have already kept a target that is actually equal to 17. You must not cross it. Okay, you must not cross it. So you'll keep adding this 1 plus 2. So now what is the sum? That is 3. Okay, still you can add another element. So 3 plus 3, that's actually equal to 6. So this whole result I'm putting here. Okay, 3 plus 3, that's 6. Okay, still that is less than 17. You can add one more element. So 6 plus 4 equal to 10. Okay, that is still less than 17. Okay, you add 5 also. 10 plus 5 equal to 15. Okay, that is still less than 17. Okay, add 6 also. 15 plus 16, that's equal to 21. It is more than 17. So you need to stop here. So you need to say, okay, I'll stop here. Okay, I'll not even go further. I'll just stop here. And once if I stop here, I'm forming one subarray. Okay, so that's the reason I'll update my subarray count to be 1. Not the total subarrays that I've created so far. So sum plus plus mean our count plus plus. Okay, now your count is equal to 1. Now where your sum will start, because now we have completed this, now we have broken at this point. So now your present sum, okay, now your present sum will be this particular area of I where you have stopped, that is actually equal to 6. Till now initially sum equal to 0, but once you have come here, that is greater than 17, so you will not be taking it. So you'll be breaking at this point and going to the next element. Now we will consider this as a new subarray. Okay, sum equal to 6. Now sum equal to 6. Now try to add another element. So 7. So what would be your sum now? 13. Is it less than 17? Yes, it completely less than 17. Okay, now we'll go to another. There is no other element. So finally you'll be increasing your count because you have come to end of the array. There's no more element to add. So this whole thing can be constituted to be a one part of subarray. Now we have got count to be equal to 2, count to be equal to 1. Right? This is the thing. But how many subarrays you are supposed to find? 3 subarrays. So I say return true in this case. Why return true in this case? What is the maximum possible sum? Maximum sum here. The sum here that you have got is 15. 5 plus 4 plus 3, 2 plus 1. Here the sum is that you got is 13. Okay. So what is the maximum out of these two, 15 and 13? So that is actually equal to 15, right? That is actually equal to 15. So what you can try to do is either you can split this particular thing, either you can split this particular thing, or you can split this particular thing, or you can split this particular thing. Whatever you want to do, you can easily split, right? Because nowhere your subarray sum would be greater than 17. You have a freedom to do it. You can do whatever you want. You can either split this fashion so that the total subarrays would be 3. That freedom you have got, that freedom you have eventually got. Leave out the final answer, but the freedom that you have eventually got it. So that's the reason you can return true in that case. But because you can see, if I just divide this element at this point, what would be the subarrays? 1 2 3 4 5 and 6 7. Okay, so in this case the sum is 12. In this case the sum is 13. In this case the sum is 3. So out of 3 12 13, what's the maximum possible? That is 13, right? 13. So you still have a scope of decreasing this 17. Instead of getting into 17, you can still reduce the target. Either you can go for 13 or you can go for 12. There might be another chances as well. So that is how you need to think. That is how you need to actually think. So you can come to a conclusion that you can still reduce the target, you can still increase your greed and decrease your target and go up with the least possible maximum sum. So that is how you'll be doing it. This is a perfect binary search. I hope you people have understood the basic parts. I've tried to explain very properly. So the same thing I've put in the code. So first one, int low and high, both ranges. And if suppose k equal to 1, return the high, that means the sum. If suppose k equal to n, return the low. Instead of doing all the calculation, just return the answer here. Now do the binary search. So int mid equal to low plus high minus low by 2, and check if this mid is possible. If that is so, work on your grid. Just reduce the target. High will be equal to mid minus 1. Else you put low to be mid plus 1. Now you are increasing your target. If the target that you have fixed is not being possible, increase your low. So how do you do the binary search? Int number equal to 0, sum 0. Number denotes the number of subarrays you have formed. Sum denotes the 0. So if a particular array of I is greater than mid, so you have to put a target that each subarray sum must be less than or equal to the mid. And if you're suppose your particular element in itself, that particular element itself greater than mid, can you include that into any subarray? You cannot include. Even one subarray is constituting that particular element into one subarray is also not possible, because the overall subarray sum is getting more than the mid. So in that case you return false. No, that is not possible. Else you add that particular element into your sum, and if your sum turns out to be greater than that particular target, now after adding, that means you can not include that particular element into your particular subarray. So you can just do number plus plus. So this is bifurcation point that we have discussed here, right? So this point we have talked about. This particular point, we have talked about. So the same thing here. So you can just increase the number plus plus and sum to be array of I. So finally number plus plus. So once you reach the array, end of the array, do number plus plus to total number of arrays, and if that number turns out to be less than or equal to k, return true, or else return false. That's it. So after you if this comes out to be true, your answer will be made, and you'll try to reduce it further. You'll try to reduce a target further, okay, till it's not possible, okay, till that is not possible, till that you'll do it, and finally you'll return the answer. That's it. So I'll even submit the code for your reference. Yeah, it's got submitted. So I hope you people have understood. I know it's a long video, but I made sure all the basics that mostly don't cover all these things, but I make sure I've covered all those things, so that in the later problems you'll be able to solve it very happily. And also for your reference, codes in C++, Java, Python are there in the description. Please go through them. And thank you for watching, guys. Stay tuned.